Welcome to Nameless Debate Radio, where radioactivity is contagious. You can join us in broadening our minds on the Nameless Debates Discord via the link below, and even feature here yourself, if you've got what it takes.
Sequence, right? And you're saying that sequence in this sense means both temporal and in order. And I'm saying, actually, we just mean in order. It has to follow the correct order. It doesn't have to be in temporal, like linear progression. Not at all, right? So when something happens using quantum mechanics, it is following sequentially the logic of quantum mechanics. I fucking guarantee you. Just because you don't know how to do them.
Dude.
So, no, that's sequential. The fact that it doesn't seem sequential in your time space.
But are you saying, like, are we clearly talking about sequential logic here?
Okay, look.
Or
quantum mechanics. Quantum mechanics, right? It has a set of principles that govern it. Do you agree with that?
Yeah.
Yes, okay. Yes, the sequences of quantum mechanical phenomena follow the rules. Yes or no?
Yes, of course.
Then they're sequential.
What about the uncertainty principle?
It's irrelevant. You're talking about subjectivity. I'm talking about in the objective ontological sense, they are sequential.
Sequential, okay.
You know, there's a solution to this.
Is it to kill Terrence?
No, Terrence, there's a solution. And it's to accept that what is being presented to you is correct. And that maybe your understanding of the world was flawed and imperfect.
Yes.
I'm not trying to be condescending. That's literally
do whatever you want, dude. I'm not listening to you.
Okay, that was a little uncalled for.
Yeah, because I'm concentrating on something else.
That doesn't make it okay to do that.
I kind of missed this whole thing in my search for where the mode is for monism.
No, I just have to manually assign that.
Manually? Oh, you've got more roles. Or something.
Well, I changed them. I added the new ones ages ago, but
yeah.
Felix didn't write the text properly, so I have to rewrite it.
That's alright.
God damn it, Felix.
I know.
What's a psychonaut?
Someone who takes a lot of psychedelics.
I see.
You talking about the game?
No, I'm talking about psychedelics.
No, I'm talking about psychonauts.
Well, there's a game, yeah. Dude, Insync. Could you give me a definition for logic?
For logic, sure, structure. Specifically, consistent relational structure.
Okay. Structure for?
Anything.
Like, can we call any structure logical?
Logic is the term for any structure which is coherent.
Coherent. So is it what is it used for? Like,
doesn't have to be used for anything. That's the name of the structure.
Grounding us in reality. That's what it's used for.
I mean, generally, it can also be described as...
No, because then we're equivocating between the two types of logic. Right, because on the one hand, logic is something that grounds us in reality literally, as in logic is what we call the rules of the reality that keep us all here. But it's also the system that we use to understand it. And those two types of logic are very different.
What?
A what?
I don't know.
It's a pretty cool conversation, to be honest.
Well, I missed all of it, so fuck you.
Don't worry,
No, I
I'll
missed the first half
start.
of the shit show, and it sounded beautiful.
I'll start asking you guys about synchronicity, and then you'll stop having a good time.
Do you think we will ever come
I
to
was
understand?
enjoying that. I had to go. Fuck.
Do you think we'll ever come to understand all of the different pieces of logic? Do you think we'll ever make a description of reality that is
Yes.
perfect?
Yeah.
I don't know about perfect. Definitely accurate.
There will always be uncertainty.
Yeah,
Holy
I'm sure
Nonetheless, though, I think that despite the uncertainty, we could come up with an accurate model.
I think so too.
like how long until we come up with an accurate model? Like, do you think it'll be like thousands of years?
I think it'll be in the next 200 years.
I don't know about that. Like, the universe doesn't have an obligation to allow itself to be understood by humanity. You know what I mean?
Except science is already doing that, so.
Yeah. Well, like generally, like classical mechanics to quantum mechanics, right? Like, the universe is under no obligation to be understood in the next 200 years. You know what I mean?
Of course, but I think what I'm saying to you is that it looks to me like, based on the progression of history and science, that in the next 200 years, we're like significantly more likely to discover that kind of thing than even in millennia gone past, because we have access to so much more information and so many more resources today.
Yeah, that's fair. I feel like if we don't get it soon, we're probably never gonna get it. You know what I mean?
No.
I feel like we'll probably blow up the planet.
Yeah, like
humans are kind of pieces of shit.
word.
200 years, that seems very pessimistic.
I don't know, dude. When I think of the last 200 years, I see America dropped a nuke on Japan, and it doesn't look good, dude.
That's a good point. It might take us a much longer time to think that considered.
Well, the planet survived. It's just a matter of whether or not life will survive on the planet.
I mean,
No. You underestimate the nuke I'm gonna use.
Oh, okay. The nuke that you're gonna use.
Yeah, dude.
Because that fucking toilet is not going to handle it.
You underestimate the sauce that they put on at Taco Bell.
You underestimate how fast I can run.
Fast as fuck.
Can't outrun that.
You still underestimate how fast I can run.
You
I
underestimate
am, clearly.
how fast.
No. The thing you underestimate is that Vivi's just gonna wear his traditional garb, and then they'll stop chasing him because otherwise it'll look racist.
Yeah. Actually,
Can't
I'll
chase
agree.
the Muslims
No,
around.
you can't get blown away if you agree with a nuke.
If you agree with a nuke.
Yeah, what if you're getting like a blowjob and then you get blown up? You know what
Sounds pretty cool.
A nuclear blowjob?
Can you get blown up if you're already being blown?
I think probably.
Yes.
Yeah, but then you can say you had like the best blowjob of your life.
Perhaps if you exploded at the
last,
point
yeah.
of climax, I don't know.
No, you could say the blowjob that I was receiving just before I died had an extremely explosive climax.
You could say that.
What if you're an extremist Muslim Islamist radical? Could you say you had a radical blowjob?
I don't know, Vivi. Could you?
What if your cum short circuits the triggering mechanism for the hydrogen bomb?
So you're saying now that you're getting sucked off by the bomb?
No, I'm saying you get
a nuclear vacuum. Yes.
You're getting sucked off, and then that makes the bomb explode. So you had like, you know what I'm saying? Like
So
very
you ditch the
explosive
trigger?
climax. Yeah, very explosive. No. Like there's imagine like wires,
I'm just
right?
confused at this stage.
Imagine like there's a triggering mechanism for the nuclear bomb, and you come on the mechanism that makes it go off, and you like short circuit it so that it like goes off. You know what I'm saying?
This is like a weird Rube Goldberg machine or some shit.
Exactly.
No squash.
Except it requires semen to activate.
Exactly.
When you jizz on this target, the bomb will
I can't even
explode.
begin to-
Deposits, please.
Is it like that it reaches critical mass because of that?
No, you just short circuit the triggering mechanism with your cum.
No, dude. You come inside it and it just wants to get away from itself, so it blows up.
Yeah.
I fucked a girl in an apple. Fuck! I fucked that up. I fucked a girl in an
That's
apple.
a shame.
I fucked a girl in an apple orchard. She even let me come in cider. But ching.
Good for you.
Well,
I don't understand the joke.
Get it? Cider. Apple
Apple
cider.
Oh, okay.
Cum and cider.
You should have enunciated that a bit better.
Yeah, I know.
You should have.
I'm bad at my delivery.
It sounds
Also,
like
I stole that joke from Bo
cider.
Burnham.
Sounds like what?
He's ruining cider.
Bo Burnham. Yo,
Yeah.
Insync.
I don't know. Terrence probably likes his cider with a bit of cum in it.
Insync. I did
What?
not concede yet. I'll continue.
That's cool. Yeah, let's get into it, dude.
I'm sure you can find something. Keep going.
I believe in you, Terrence.
Terrence
I
will
don't
uproot
need your.
all of the
I
logical
don't need
systems.
your condescending sweet nothing. Sweet.
Eat
Actually,
a big dick.
I just realized, like, what about like the assuming logic? That doesn't require logic.
What do you mean?
No, I mean,
Like, you can't use logic to assume logic. That's
In
something.
a sense, that's still just the first step, and even then, it's sequentially built off that. That's the first step of logic, and then you
but
sequentially.
there's the inference of logic, and then there's logic itself.
Yeah, but you're literally sequentially building from it.
Yes, but you're bound to sequentially interpret logic because of your perception, but logic itself, I think
If
there are
you
ways
still
where-
haven't demonstrated that it is not, Terrence, and we have largely demonstrated that it likely is the way that we are describing it.
Get pooped.
Okay, I'm not saying absolutely that it exists. I think it's likely to, and I'm not like, it's not a us versus them thing, Julius, as you might think. So I'm learning too, dude.
No, it's not even I'm not saying it's an us versus them thing. All we're doing is describing what logic actually is, and you just happen to disagree with that.
So wait, what was your description?
I didn't disagree with any definition of logic as far as I know.
I brought up that I said
Actually, you did, Terrence.
Yeah,
just
he
so
did.
you know.
I brought up that like logic is sequential.
Sequential, okay.
Yeah, and he disagreed. Which is, and like that's exactly why like we have logic is literally sequential. And when it's not, it's not logical.
So
So
wait,
we can construct logic that is time independent.
Logic.
Oh,
No,
there we go.
no.
Wait. You just pinpointed it, Terrence. For the 5th time, there's a difference between sequential and temporal.
Yeah, we don't mean sequential as in time. We mean sequential as in flowing from point to point. The
Yes,
points don't
it
have to
follows the
come
rule.
in a time order. They have to go in a sequential, logical order that is independent from time.
Yes.
So they build off each other's points.
Yes, and they follow the rules that are the
And when
like
you are not being logical, VV.
Mm-hmm. Yes. And that's what we mean when we say non sequitur. We mean you failed to follow from point to point.
I see. So making those leaps.
Yes.
Well, connections is better than leaps.
Yeah, leaps is usually the word we use to describe a connection that wasn't good.
Yeah, leap
Yes,
is
kind of logic, right?
Because it's supposed to be step by step. Leap implies you missed a step.
Yes, and that's what I was saying. I was saying that's what you don't want to do.
Dude,
No, I know, but I feel
What
like
kind of logic are you
doesn't everyone walk
discussing?
up the stairs
Logic
two at a time?
itself is massive.
If you miss a step,
Logic
it
itself?
hurts.
I mean,
Yes, we're
not
describing
formal,
that.
not mathematical logic.
No. We're explaining how logic, mathematical or formal, is sequential.
It's not always sequential.
Oh,
It is
dude,
always
my
it
sequential.
is always sequential. Stop returning to the temporality thing. I'm fucking sick of it.
We've already addressed the temporality thing.
Yes, I know about the temporality thing.
No, we've already addressed it. It's not.
No, but the
a
point
valid
is
point.
that is the only way that you're making this fucking random claim that it's not sequential. You are only saying that in the sense that it can be time independent, but we already said that doesn't mean the thing that you're saying it does.
Okay, so when we're talking about logic, are we talking about fundamental logic, or are we talking about like logic as it's implemented?
I was talking about both. I just said, when he asked me for a definition of logic, I said consistent relational structure.
Okay.
Wait, you said consistent relational structure?
Yes.
Oh, I thought you said okay.
What did you think I said?
Structure.
I did.
Structure that is coherent.
Yes, that's the same thing. Coherent and consistent are the same.
But isn't logic
different.
a consequence?
No,
of...
they're not, Terrence. Like,
Does logic-
coherency is consistency within a limited frame.
Does the logic apply to the Grand Old Duke of York?
He had 10,000 men.
He raced them all right up the hill.
And he raced them down again.
Okay. Lamassive, did you want to try and disagree with us and myself and Instinct?
No, I'm just curious if you agree
Here's a question. All right, so like we have something like Occam's Razor, and it's said that arguments.
Occam's Razor is a heuristic, to be clear.
Or so it's not logic.
Newton's
heuristic.
No.
It's a tool.
Yeah, it's a tool. It's a heuristic.
Is it a logical tool, or is it just?
No, Vivi. It's not it's not an element of logic. It is an artifact of logic. There's a difference.
Okay. So what does artifact mean?
Artifact is like something that is produced from the thing, right? So I'm saying like Occam's Razor is, for instance, the principle of explosion. That's not part of logic, dude. But it's like something that we've noticed that is a really good tool, because what we can do is we can say, well, the principle of explosion basically is this idea that if you start with contradictory premises, you can derive any conclusion. If you're okay with contradictions, you can get anywhere.
I'm just curious. Are you trying to talk about syllogism or whatever it's called in English?
Do you mean syllogism?
Yeah, whatever, syllogism.
Syllogism
sequential
is
of a premise that you.
Syllogism is argumentation. That's not what is specifically.
We're
what
literally
we're
just
doing.
talking about how logic
you
itself.
have to define logic then, right?
Dude, wait.
I already did.
Insync, I have a question. How do you qualify a structure to be logical?
Is it consistent with all other structures?
No, the structure only exists itself. Like
then is
that's
it consistent? Is it consistent with itself?
What do you
that
mean by
makes
that?
sense.
What do you mean by that?
I mean, does it contradict itself? Obviously, like there's nothing else I could mean.
Like a great example would be the E8 geometric structure. Right?
Oh yeah,
It's
that's an interesting one. But it doesn't. No, it doesn't contradict itself, so it's logical.
Yes.
If it's the only structure, then yeah.
So anything that doesn't contradict itself is logical.
Listen, dude, you are the one who predicated it. If there is only one structure, then if that structure does not contradict itself, it is logical, yes.
Okay.
Something that you tend to do, Terrence, is
Yes, of course.
Listen. You inject stuff that should be there, right? But then you fail to articulate it when you repeat what the other person said.
But I did get your point.
No, you missed the bit that you said, mate. Right? Like you said, what if there's only one structure?
That's only
right?
only one structure.
No, but
yes,
listen.
of course.
No, but listen. When you repeated me, right, what you said was So, if a structure is internally consistent, then it's logical. Now, can you understand why that's not actually what I said?
Yes, because there is only one structure we're talking about.
Exactly. And so it's weird because you're specifically the person who brought up the one structure thing for you to then miss it out of your explanation.
Didn't miss it out. You expected me to miss it out. You think I missed it out. I didn't miss it
So you're
out.
saying it was implicit. You're saying it was implicit.
You implied that
guess
I
what?
missed
Guess
it.
wait. Guess what? It being implicit is you missing it out. That's your fault. It shouldn't be implicit. The job of philosophy is to make it explicit. That was your fault.
Fine.
That's a fair point.
Yeah, dude, it's not a blaming game. Like, holy shit. 1 point.
Well, I mean, you said that I made the assumption that you missed something, but I was right. You did miss something.
No, you weren't right.
No, I was. Dude,
I might
the
have
failure...
implied-
No, but I'm saying
wait,
the
wait,
failure to make it explicit is the bit you missed.
I might have implied that I missed it. That doesn't mean I missed it. Like,
No, dude, you're not listening to me, okay? I'm not saying you missed it inside your head. I'm saying you skipped a fucking step, dude. Jesus Christ.
You skipped a step and you didn't. You
I
were
skipped
not
a step
sequential
because I
in your
asked you.
reasoning. Do you
Wait,
understand?
I skipped a step because I asked you if something is internally coherent, then if it is logical or not. That was just
Yes.
a question. That
No, but
didn't
the thing
imply.
is, no, Terrence, god damn it. I don't understand why you're not grasping this, dude. That question is ambiguous. There's two answers to it. The first answer, the general answer, is no. That does not make something logical. In the specific context you stipulated, yes, that makes something logical. But since when you asked me the question, you didn't add the context you stipulated again, it was very fucking confusing.
Wait, do we want to continue the conversation instead of going off on this? Because we're not really getting anywhere.
Of course.
Stop. No.
A lot of people like to pursue gotchas when they think they've got one.
Yep, so let's continue.
Wow.
Trying to do fucking homework and you guys are
So,
constantly arguing in the background.
So, Terrence, what were you trying to say? Like, what was your point?
It's nice as background noise, but only when the debate's entertaining for me.
Fair enough.
So change the subject.
So
it'll suit me.
How much of a fucking nerd is Hoovus?
A very big one.
This is an interesting
Would seem
topic.
that way.
I'm doing ethical hacking homework right now.
And you don't find this entertaining?
I don't know, actually, I like it. What were you debating? Logic?
Yeah.
Yeah.
I'm still. What is it that you say logic is? I'm just curious.
Debating
You
if
didn't
it
say
has to
formal
follow or
mathematical.
not.
I was probing.
Because I didn't hear the start, so.
I was probing him about logic, right? And I gave him a specific example. If one structure existed, if it was internally coherent, then if it was logical, and he said yes. And then I was like, okay, so is every structure that is internally coherent logical? That wasn't based off on the one structure thing. It was in general. If you have
Yes,
a
and the
structure,
answer to that is no.
yes, you could have said that. There is no ambiguity, right?
I did say that.
Yeah, yes, if you want
instead
to create ambiguity, you can.
Hold on.
I'm not fucking creating something,
Instead
Terrence.
of
Don't fucking
instead of
project.
hold on. Instead of dicking each other down on the specifics, why don't we just continue the conversation and leave this whole like you said, she said type of thing at rest.
So
So,
what qualifies a structure to be logical?
Lamassive.
Yes?
The definition of logic that I use is consistent relational structure.
Alright.
You asked for a definition, that's the definition I'm using.
Okay.
So, what was your question, Terrence?
So, I'm just
What
curious.
qualifies-
Would you also not agree with the deductive reasoning, for example? Do you agree with that as well, then? In the same
Of
sense?
course, yeah, no, but I'm saying the subjective system of logical reasoning is a subset of the category of consistent relational structure.
All right.
Okay, my question was, what qualifies a certain structure to be logical? Like, if
Being
it doesn't
consistent, being
yes,
consistent with all the other things that are.
If that is a structure, could you
okay.
perhaps use atoms in relation with something else?
Or even just information. would
Wait, so like a
probably work.
black hole isn't logical?
No,
Because
but
it doesn't.
no.
Trump
Information,
said it doesn't.
systems of information, right? So like abstracting to like atoms, right? You could say, oh, well, photons aren't logical. Oh, black holes aren't logical because they're not atoms, right? But all that stuff contains information, right? So I think what
Yes,
he's
of
talking about
course.
is a self-consistency with other systems of information, right? Which kind of
Yes.
gets rid of
Yes,
this whole photons or black holes or
yes.
whatever.
Bringing information as the constituents of data when it comes to relating something as
Data is
correct
the
or not.
constituent of information, not the other way around it.
Yeah. Terrence, you can have a system with completely random data, but that system still contains a massive amount of information. In fact, random data contains more information than structured data because of its reduced redundancy.
Of course, yes, the syntax.
Like Shannon information is a good
But
place.
yeah, I would agree that yeah, like data is the constituents. You got me there in sync.
I mean, I had you there from the beginning, dude. We both knew that's what I
Wow.
thought.
Yeah, like this is.
Like,
Yeah,
It's
it's
okay.
not
You
the
gotta go through
first
the
time you've
steps to
heard
get
it.
him there.
I knew Julius would say something.
All right, so let's just continue.
What? Wait. What? No. What? No. Don't be dishonest, Harris. Like one, this started because of a comment I made. So yes, I'm going to make a comment. Don't try and get
Yes.
little jabs in when you fundamentally been
That's
demonstrated.
what
to be
you
wrong.
do to me. That's what you did to me. That's why I'm doing it. It's
And
just
Oh, what a
you're
cute
just-
love story.
exactly right. It's
And
wholesome.
Okay, guys,
Terrence,
instead of
so
digging-
no, so you admit unequivocally that you were incorrect about sequential logic, yes or no?
Stop
Dude,
holding
listen, I'm gonna
No,
postpone
yes or no?
that logic.
No, don't answer that.
No.
Don't answer
Wait, Julius, come
No,
on.
I'm pinning him on
We
this.
should.
You're berating
we
my
should,
client.
No, but we should accept he's gonna postpone his decision. Like he got wrecked, dude. Everybody knows.
Yeah, he got
this.
wrecked.
It's on recording.
And because he got wrecked, he decided to retreat back into the haha. I'm going to go back to my trolling mockery because I don't have any points.
That's not what I retreated to, dude. We're
instead
talking
of
about
instead of dicking each other down on he said she said, why don't we continue the
please,
conversation?
Julius, let's move
the
on.
conversation's over, and he wants to be pathetic.
Well, why don't we continue the conversation to hammer that point home, right?
We might have. You may as well just have a different conversation because there's nothing more to gain.
Okay, can I ask something?
Yeah. We're gonna talk about logic now. So yes.
No, can I ask, do you think a lot of people think that logic constitutes the same as truth? Do you think a lot of people think that?
I think that is a pretty common conception. Yeah.
But do you think it's correct or that is wrong?
There's something about it that's correct, but it's not simple. So like it's the thing I was talking about before, with the distinction between the category which is consistent relational structure and the category which is a system that a subjective individual is using to interpret the world, which is as consistent as they can make it, right? There's a big difference between those two things. So, although I do think that what is true is what is consistent and related to everything else that's consistent, right? I do think that my definition of logic is the formula for truth. I'm saying, like, the subjective thing that we call logic and the subjective thing that we call truth don't match up to those objective notions. And what we're often saying is that we're most likely to, articulate or approximate what's true when we think logically. That doesn't make logic equivalent to truth.
Well, I agree with that. So,
dude, do you think all forms of syntax are intrinsically logical?
Yes.
See, that makes more sense. Like, damn.
Of course I would think that.
So can you derive syntax out of any constituents?
That's kind of what the laws of physics are.
Derive syntax. That's a strange one.
That's
What are you saying, like can I derive syntax out of constituents that have syntax, or out of constituents that don't?
Well, do you think like the core constituents of everything, does it intrinsically have syntax, or
yes,
is it
I think that. I think
that's,
so.
That's what the laws of physics are, right? Any physical system has some underlying syntax to it, just from its physical nature, right?
Yeah. So, sus's?
Sus.
I tried, but like information, right? So like regarding information, what happens to the information that goes inside a black hole? Like what, according to
You're thinking too temporally again.
No, wait, I'm just asking. I'm like just,
It's still
No, but that particular like question doesn't come into like, I don't frame existence in terms of physics. So when you're asking what happens to that information, even if it did exist, even if, and I don't think this is true, it did stop existing in a temporal timeline, it would still exist in physics forever. So that doesn't make it not exist. So, like, you're asking what happens to it. Nothing fucking happens to it, dude.
Yes, nothing. No. Something happens to it. It doesn't stop
No.
existing. No.
But that's what I'm saying.
It doesn't stop existing.
Yes. Space-time continues to transform. That's all that happens.
Yes, of
Right?
course.
Like,
So what?
So it's like asking like what happens to the particles that were there immediately after the Big Bang. You know,
Dude,
like
you know what I'm trying to express, dude.
dude. Okay,
like,
so
why are you
hold on,
stretching on this point, though?
Hold on. So a black hole's surface area is directly proportional to the amount of information stored in the black hole, right? So that's kind of
like the accretion disk. Like
no. So if stuff enters the black hole, its surface area increases. So the information is kind of, how do I say this?
Translated.
It's translated into mass. It's translated into the overall surface area, right?
It's translated in the interaction, obviously.
Yeah, like it doesn't just disappear or like go into transcendental woo-woo space or whatever.
I guess that makes your like entire question a bit confusingly phrased, Terrence.
Dude, I said what happens to the information when it goes inside a black hole?
It transforms, obviously.
It turns into it increases the mass of the black hole, because in physics, information, energy, and mass are effectively equivalent to each other, right? So it's weird.
So like, but what about like a black hole evaporating? Like, how does that weigh out?
The information comes out of the black hole given enough time. That's what Stephen Hawking discovered when he came up with the concept of Hawking radiation. So, like, the information doesn't disappear. It still exists physically in some form or another.
You just can't see it properly.
Yeah, it just takes a really long-ass time for the information to get out of the black hole, right?
It's like, I dropped a ball down a really long hole, but the people at the bottom haven't got the ball yet. What happened to the ball? And it's like the ball didn't reach the bottom yet, dude.
Okay. The better phrase would be, what is happening to the information as it enters the black hole or whatever.
It gets encoded into the surface of the black hole. It becomes the surface area. It becomes the mass, right? That's kind of because information, mass, and energy, they're all the same concept in physics. So it's kind of
Matt, who is this fella speaking? I'm not at my computer. Yeah, of course it's possible it gets distorted, as in it doesn't look like what it used to look like, but that's irrelevant. It's not objectively distorted.
Yes, it gets translated, as you said. I understand.
Yeah, it turns in, like, the information turns into the black hole, essentially. And then eventually the black hole turns back into the information, or the photons or whatever that made it up, right? And do you have any more questions, Terrence?
Whoa, what?
Well,
I
not
heard a
really
lot of
regarding
things,
black
and I
holes
heard
at the
photons
moment.
be thrown in there, and I'm like, what? Can you repeat that, please?
Like, say you have a photon that enters a black hole, right? The photon, the information inscribed in, like, the information in that photon will be
the information that the photon constitutes.
Deconstructed. It gets deconstructed.
And we are sure that it doesn't react with anything present in the black hole, or it's
basically anything that
reacts with
enters
gravity.
anything that enters contributes to the mass of the black hole, and eventually the black hole will decay back into photons, right? It'll undergo Hawking radiation and spew its guts all over space really slowly.
Yeah.
What about white holes?
White holes don't really exist. We've never observed one. Like, some people say we have, but as far as I'm concerned, they haven't demonstrated beyond a reasonable doubt that we have observed them.
Proton decay.
Yeah, proton decay hasn't been observed either.
Yeah, I know. Yes. It'll take a long ass time.
Yeah, that's why we haven't observed it.
But yeah, man, you seem pretty cool.
Yeah, relatively bright as well.
I mean, I have a light right next to me. Do you have any other questions about information physically speaking, Terrence?
You know about the E8 lattice, right?
Yeah.
And like, do you know about emergence theory?
Oh, are you talking about the Quantum Gravity Research Institute? Like the stuff that they've been doing?
Yeah, I guess, yeah.
I mean, they throw around a lot of cool ideas, but I guess time will tell if their ideas are accurate.
Yeah, I mean, like, if they can accurately describe why the speed of light is what it is, then that would be a good consideration.
We already know why the speed of light is the way it is.
Like the exact speed?
Yeah. Because all of the physical constants are relative to each other, right? So if I halved the speed of light right now, I would need to mess around with all of the other constants of the universe, and it would look like nothing changed at all. So that's kind of why the speed of light is the way it is. It's a self-defining system, because that's kind of what physics is when it comes down to it.
I'm curious that you said all
but
photons will be spewed out by Hawking radiation, right? But
yeah.
That's just basically
what
energy, right?
What about when there's only 2 photons left? Is it a black hole still then?
No, then you get Neil deGrasse Tyson, right?
Yeah. So when there's only, how do I say this? When there's only one photon left, the black hole will decay into a photon that has the maximum energy possible that a photon could have.
But why is it still a black hole when there's just one photon? Like, isn't it just a photon then?
The problem I have with
I think
that,
that's extremely a big misrepresentation of what we understand of black holes in science.
But my problem when you said information.
Well, we
comes
know
in
black
and then it
holes
comes
are
out.
not necessarily that small. First of all, they're very, 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 very large.
No, generally they're very dense. They tend to be quite small. They tend to be quite small, Vivi.
Relatively, but relative to us, they're still huge.
Well, they're
not necessarily.
Okay, so let's
they tend to get huge very quickly.
No, yeah, okay, so let's see what's the size of a black hole.
They're not big in the grand scheme of things.
Okay.
They're super, super, super heavy, right? Like
billions
of times the mass of the sun.
So when you said that information goes in from a black hole when it comes out, are you just meaning that energy is going in and the same amount of energy is coming out, or is it the exact same energy that's coming out?
Yeah, like
he's saying that there's an equivalence between matter, energy, and motion and stuff.
Of course.
And that through the equivalence, the energy which is the information which is constituted in any particular form, it shares the commonality such that it can be translated, right? He's saying whatever information is persistent between the forms, right? Whatever is getting translated from energy into mass, that gets saved in the black hole and then ejected.
Yeah, so the information.
Has this been proven?
What comes
Okay,
in?
look at this. Look at this. For 3 solar masses, the radius of a black hole is 13.5 kilometers.
Yeah, because it's the maximum density. It's the maximum density object that can exist within our universe, right? So
as far as we know, right?
Like you can't make a black hole more dense. You can only increase its volume, right?
As far as we know.
I'm pretty sure you can definitely make it more dense.
Wait, no. You can't make it more dense. You can only increase its volume.
Yes,
right?
that's correct.
So like,
I'm still very sure you can make it more dense.
Vivi, I'm pretty sure. Vivi, yeah, I'm pretty sure by definition the way black holes work is that it's like as dense as it could possibly be.
Yeah.
No.
In our understanding of the universe and the becomes dense enough.
What happens is it becomes dense enough such that electromagnetic radiation can escape.
Yeah,
but no. That's a very subjective definition of it, because by the time it is that dense, right?
Yes.
Like we're talking like the internal gravity collapses the classical structure of matter. So we're talking about like whatever matter is inside a black hole. It's compressed well beyond the limits of what we can understand, and there's no reason to think it can be compressed further.
Yeah, so you can't.
Why no? Why suddenly we have to have that wall and say, okay, it can't be compressed further?
Because
why should it be able to?
Hold on. So a black hole is it's a region of space that light cannot escape, right? It's a boundary, right? It's like a spherical boundary, right?
Yes.
And if you add more mass into it, right, the boundary expands, its volume increases, right? But the density of the black hole itself doesn't increase. That's what I'm getting at. Like, you can add more stuff to it, yeah, for sure. And
okay, actually, let's look at the equation, the radius equation for a black hole, and see what
how do I say this? The amount of information that can fit into something is proportional to its surface area, right? Like it's the holographic principle kind of stated that the surface area of a boundary that has more to do with the amount of information that can fit into it than its volume, right? So I guess like if you increased the volume, or if you increase the surface area of a black hole 1,000,000 times, then hypothetically you'd actually be decreasing the internal density. You know what I'm saying? I don't know. I might be wrong on that, but I still don't think you can.
You would have to keep the to decrease the internal density. You'd have to keep the internal what do you call it, volume constant for the increase in surface area.
So I don't know if you can increase surface area but keeping volume constant.
No, that's what I mean. You
can. Oh god, you can definitely increase volume without increasing surface area, and vice versa. You can increase.
In this situation, can you, Vivi? Can you show me doing that with a black hole?
In a sphere, can you increase the surface area?
Yeah, I'm pretty sure you can't.
Volume?
Okay, so that means we have to fix it as a sphere, which black holes are definitely not.
Well, okay, so black holes are mostly spherical unless they're spinning, but usually the stuff that enters them, its momentum is pretty random. So they're like
just like. Is there a shape you think it's closer to, Vivi?
No, sphere. It's mostly spherical, but I'm saying it's not exactly spherical. I would say.
But is the representation is the representation based on an exact sphere, or is it based on a spherical shape?
Even
if it shape.
Even
Yeah.
if it was egg shaped, right?
Yeah, I'm saying, as far as I understand it, any spherical shape, you can't increase the surface area without increasing the volume.
No, you can. Like
How?
Earth,
Mathematically,
right?
you cannot.
Mathematically, you
Would you
can.
say the Earth is spherical?
Dude, no, like mathematically, you cannot.
Okay, if you
Like-
fix it as a perfect sphere, but the thing is, you can change it.
No. Use an egg. Go run a simulation with an egg
Yeah.
where you increase the surface area. I guarantee you the volume will go up.
So how would
Dude,
you
it's the Banach-Tarski paradox.
but how would you make the volume stay constant while increasing surface area? Right?
By increasing the number of quote bumps or mountains that are on the surface.
Yeah, okay, but are black holes
Yeah,
bumpy?
you can
from
fractalize. You can
from my-
fractalize.
From my understanding, it's just
Okay,
a
no, that's
boundary
true.
in space.
But I thought it was implied that the transformation we were making was universally distributed. Right? Increased surface area. That sounds quite generic. It doesn't make sense to me when I say increased surface area that you'd think, we're going to like make a lot of peaks and valleys in the surface we already have. It seems intuitive that I mean expand the surface area with a universal distribution.
Also,
of
if
increase.
if
You
you
know
think
what?
about
Alright.
it, if you
Apologies,
think about
forgive me. Then
it,
I didn't know that
the
you meant
mass
that.
that enters the black hole almost instantaneously arrives at the center of it because it travels like at the maximum speed limit, right?
Actually, that wouldn't be plausible because it wouldn't be able to
Like,
get.
it's faster than light. Like
Yeah, so-
information transferred there is faster than light.
Yeah.
That's also seems to be very false.
Okay,
Well,
well,
you see, information is like
Yes.
intrinsically can be faster because if you shine a laser on the moon and then like sweep your hand across it, like the photons landing on the moon sequentially will be faster than
yeah, but
how a
Terrence,
photon will travel.
Terrence, your perspective of the dot going across the moon, the information that the dot is traveling across the moon faster than the speed of light, takes light speed in order to reach your eyes to see that dot moving across faster, right? So information, how do I say this? In quantum mechanics, non-locality is violated, but causality is preserved, right? Like, you can't transfer information faster than the speed of light. But in black holes, what happens? You know how we can move through space?
Don't you mean? I feel like you said non-locality is violated, but I feel like you meant locality.
Like you don't have to
is
see
violated.
the sequence. You don't have to see the sequence of photons landing on the moon's surface, right? But the sequence it will land on will be faster than a photon.
Yeah, but still, no
You
meaningful.
don't have to observe it,
Terrence, no meaningful information can be
traveling faster than the speed of light.
You can't have superluminal information transfer, right?
Yes, of
but
course. Yes.
In black holes, what happens though is you know how we can move through space, but we're like temporally moving in one direction. In a black hole, the trend is reversed, so you can move through time any way you want, but you're spatially always confined to moving towards the center of the black hole. But moving through time any way you want, doing that process accelerates your spatial position closer to the black hole. Right? PBS Spacetime did an excellent episode on this.
Okay.
But information doesn't really do anything weird when it comes to black holes. It's all very like normal. It's just an extreme circumstance of normal.
But isn't matter torn apart by the tidal forces?
Well, we also know that there are things that achieve incredible amounts of energy and like density that they become other forms of matter that are not classical. For example, we know there's something like quark stars, and those are not like you don't find electrons and protons and other things like that, but they're just literally soups of what protons and neutrons are made up of.
Yeah, but quarks are still classical matter. It's still like baryonic matter and stuff. Like
Yes, but they can be extremely more dense than normal matter.
yeah, but they can't be denser than a black hole, right? So it's kind of like, you know.
The black hole.
Wait, as far as we know, dude, because like the singularity is the
No,
densest
but
object.
like I think what he was saying is that if they're not more dense than a black hole, then the point is kind of moot, because that's what Vivi was contending.
I was contending that black holes are as dense as can be.
Yeah, but there's no reason to think otherwise at the moment.
No, I mean like to say suddenly that there is that is the limit.
Who said that it was certain?
There is no certainty around this. I'm just having a contention with the claim that that's it. That's the limit.
What if black holes is a gateway to other dimensions?
Okay, so allow me to qualify it more specifically, just for you, right?
Right.
According to what we know now, it seems reasonable to me that would be a good conclusion. I can't. It is inconceivable to me that matter could be more dense than what we have conceived of as a black hole.
Yeah, because you can't be more dense than the densest possible thing.
Can you conceive how dense things are in a black hole? I mean, can you actually conceive it in your mind?
No, I'm just saying, like, when I'm thinking of a black hole, what I'm thinking of is something that is so dense that it violates basically all the other principles of matter, right? Like, it doesn't have them. Like,
why does it have any volume?
That's the only limit.
Why does a black hole have any volume then?
I didn't say all of them. I said basically all of them.
Because it's a boundary. It's a region of space where acceleration is greater than the speed of light, right? So you can't have a boundary that the acceleration is greater than the speed of light plus 1, right? That's meaningless, right? Therefore, that boundary area is the densest possible thing that can physically exist, right? Like a black hole could have charge, it could have spin, but generally they don't have any charge or spin because the stuff that enters them, its momentum is kind of like, it all cancels out, right? So a fast-moving particle that comes in one way and another one comes in the other way, its overall momentum is not much, so it just kind of stays the same. It doesn't spin.
So why would it cancel its? Why would the direction be, vice versa?
It's kind of like you know those like playground things where it's like a flat table that spins around in a circle? It's kind of like if you had one person spinning it one way and you had another person spinning it the other way, its overall spin would kind of cancel out, and that's what we see in most of
That's an extremely good analogy.
Most of space, to be honest.
Can a still black hole start spinning?
It could if you threw like stars in it coming from one way, but they don't have that happening, right? Like they're overall like most black holes don't really spin that much. Some do, but they don't really spin that much.
Are you saying that we can get black holes to move through spinning, so we can actually weaponize black holes?
He was saying
black holes do move.
Listen, he was saying in principle you can get a black hole to spin. Like, you can do the math, and if you fucking throw stars into it from one direction repeatedly, it'll spin. But generally in nature that does not happen. That's what he said.
Yeah, like you can impart momentum into the black hole, but it just doesn't happen.
Universe Sandbox
often.
Simulator too.
So would you okay, but some black holes are spinning, right?
Yes.
Yeah.
Yes, but he said that they're not spinning in the sense that you would naively conceptualize them like a ball might spin. I think he meant that the spin was a lot wonkier and more haphazard.
Yeah, if you throw stars in one way, right, you could get the black hole to spin so that it like turns into a pancake from how fast it's spinning, right? But the region of space where stuff has more acceleration than the speed of light, that region of space still has the same density, even though it has a greater surface area. So it's kind of it's a weird set of ideas, but it works out.
Again, I'm gonna note that like
we only know anything as far as we know. It's a pointless caveat.
I'm gonna
I reckon.
So as far as we know, obviously, as far as we know, we only know anything as far as our current knowledge extends.
Oh shit!
Fucking A,
For
dude.
real?
Julius dropping the fire.
Whenever anyone says, "Well, we could," something else could be the case. Yes.
In the way that you think, if you think that, well, this is
what
the
is
outcome right now.
The thing is, there's
what
no
is
reason.
probable matters far more than what is possible. So you can just pointlessly sit there and go, what if this, 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 what if this? But that's not what we do. We look to what the evidence
So if I say
Oh,
that, but see, Julius, the thing you're doing is that you're saying that according to the knowledge we have, our knowledge about the universe is extremely.
No, Lamassive. What he's saying is, right, as long as everybody participating in the conversation is epistemologically aware and we don't have people who genuinely think that we actually know shit, it becomes kind of irrelevant to say, well, you don't know that for sure, as far as we know.
Well, it's kind of weird when you're
etc.
correcting each other then,
No,
right?
but as far as we know, could
No,
be
it's not weird.
implied in a
Simply,
polite
I
way.
don't think you understand the conversation that's going
Could
on.
be
Well,
implied
I
in a
understand the
polite way.
conversation.
Yes, it
As
could
far
be,
as we know-
Terence, but it was said a bunch of fucking times. I assented to it repeatedly.
Yes.
Oh, okay. In that
But
case,
I think as far as we know, we wouldn't have a reason to believe that a black hole is compressed in a point, like the matter of a black hole or where all the mass lies.
Compressed
is in
in
a
a point? Nobody said that.
Okay,
Nobody
so then
said that.
how come we say it's as dense as can be then? Unless
Because the boundary space, it's defined as a boundary where stuff experiences
Okay.
acceleration equivalent to the speed of light, right? So you can't say that
Yes.
stuff experiences acceleration to the speed of light plus 1 meter per second.
So we
right?
can't be talking about density. We'll be talking about volume only. We can't say we can't talk about density at all then.
What?
Yes.
Well,
okay.
We can
Like
say
if
that
we're
a
talking
certain
about
amount of
goes over the limiter.
There's
let's
mass there. There's mass and volume. That equals density.
Yes.
Like, you
density-
don't have to... Listen, you don't have to use the word density if you don't want to, dude. But insofar as we're talking about mass and volume, I'll just work out density on the side.
Okay, so we know that mass can increase.
Yep.
And we know that the volume of what increases? The
Of
volume of the
boundaries.
mass or the
vol-
volume?
Surface area.
the boundary where stuff experiences more acceleration than the speed of light, that boundary, its volume increases as more stuff gets added in. Right?
Yes.
Okay, so I'm curious. Was there a specific number for the density, or is it infinite?
So people say that it's infinite, but the actual density, like it has a finite density.
Yeah,
Trying to find
otherwise,
the
if
numbers
it
on
would
this.
start spewing out things,
So-
it would just encompass everything around it, right? Like
Exactly. If
forever
it
and
had
ever.
infinite density, the boundary space would be infinite, and it would just instantly like take over the whole universe, right?
I can immediately imagine how there can be a black hole that's less dense than another black hole.
How so?
Matter being condensed in such a way that it's not compressed in a single point, but being enough to be able to have a event horizon.
Why is it, Vivi, that you conceive of a single point as the most possible compressed thing?
Is the singularity?
Why do I say that a point is the most compressed?
Yes.
But Vivi,
Because
wait a second.
then by definition it wouldn't be able to be
But
compressed.
wait,
anymore.
Vivi, where do you think the black hole starts? Like in your
No, but
idea,
it's
right?
so confusing to me, Vivi, because like the way that you conceive of it is like it's sort of like you conflate like the idea of a singularity is in the start of space-time, and then the idea of a singularity is in something in space-time.
I'm saying like by definition, if something
No, but look, but here's what I'm saying. I'm saying like so space-time could be
Yes.
compressed into a single point. Yes, something inside space-time, insofar as it's not the whole system, it couldn't be a single point. Like you can't. That doesn't make any fucking sense to say
Okay.
that the most compressed something could be a single point when there are other things in the system is ridiculous.
when there are other things like what?
In the system, unrelated to the black hole.
Hold
There's
on.
not
yeah.
just one
Hold on.
point.
Hold on. A good way to think about black holes, right, and the singularity of a black hole. Imagine you drop a ball into a well, right, and the bottom of the well is accelerating faster than the speed of light.
Oh, I saw this presentation.
The ball going into the well won't come out the other side, right?
Yeah.
Until something like Hawking radiation eventually makes the ball come out, right? But that's a different phenomenon, right? So the idea of a singularity, it's not that there's like one point of infinite density. It's just that space is infinitely contracting in on itself. So there's not like so the ball from our perspective looks
Did you wait? So you said a few words that triggered.
Hold on. the ball from our perspective looks like it's infinitely close to the other stuff that entered the black hole,
So
right?
one thing that I'm curious about, because, well, obviously I haven't read about this, I don't really care that much for it, but I still understand some of it. So I'm just curious, what form does a black hole take as it expands, taking in new, sources of matter?
Okay, so this is how I think about it. I think the way I think about a black hole is it's like a star, but the thing is, it's massive enough to be able to create its own event horizon, and in that event, it becomes extremely more dense because the gravitational pull is so great that it makes light not be able to escape.
Okay, but I'm curious
That was
about
a
the
strange
form.
explanation. It becomes heavy enough or big enough to make its own event horizon. What do you
Yes.
mean by that? What do you mean by that?
Okay, so we know that gravitational lensing occurs when there's a object that has a gravitational pull and a light what do you call it? A light bends towards it. So
Yes.
in the event that this object that's creating this gravitational pull has a gravitational pull strong enough to loop the light around it, you get an event horizon.
Yeah.
Okay. So you're saying it doesn't create its own event horizon. It gets heavy enough that it acquires an
Yes.
Yes, but the light, if it gets heavy enough, then the light will just go straight in. Like, why would there be a loop?
Well, like
No,
Because
actually
things-
can't.
What?
You can't have something go straight in. That's impossible.
You can't have a loop if you have like a angular
you would-
momentum.
You would
An
literally
angular-
need an endless gravitational pull, which doesn't exist, as far as we know.
What if you pointed yourself directly into the black hole?
Then that's
You just go straight in, bro.
special case.
it's like hold on.
No, that is a special case, Terrence. Why would anybody do that?
Hold on. Imagine you know those like little things that you see at the mall where there's like a coin that spirals around and eventually it goes around the spiral long enough to drop down? It's kind of like
Yes.
that, except the end point of that is being stretched out faster than the little coin can roll around it. And then eventually when Hawking radiation happens,
Yes.
the coin pops out.
No, look, I get it. But I think what Terrence was saying is that what if you roll the coin directly towards the center, down the side, rather than around?
Then
Like,
it would go
no
straight
angular momentum.
No, actually, it would go straight through. That's what would happen. Wait. Yeah, it would go straight through.
It would go right through, yeah. Like it wouldn't matter. And then when
So,
it's
like-
on the inside, it'll start rolling around the thing as it's being stretched out, and then Hawking radiation will slowly make the stretching out of the little spiral thing slow down and slow down and slow down until eventually the little last piece of information hits the bottom and then gets emitted as a maximum energy photon.
Or proton decays.
Yeah, but proton decay doesn't affect the stuff inside of a black hole because it doesn't experience time the same way that we do.
Wait, but after
Did you say
evaporation,
protons or
right,
photons?
protons still exist.
Yeah, so like it wouldn't matter.
I'm pretty sure if a proton ever enters a black hole, its chance of colliding is very, very, very high. I'm very sure it's gonna get smashed and then become other particles.
Yeah,
Whoa.
so another misconception is that stuff inside the black hole hits the center, right? Nothing really hits the center. It's like a coin spiraling down a spiral. It's just the end of the spiral is being stretched out faster than it can hit the end.
Well,
Material information is
if everything is the same density, that would have the same amount of gravitational
Just quickly.
pull, wouldn't it?
So,
And if it has the same gravitational pull,
what's your
it would
name,
just be-
Sus?
it would expand
Zeus.
in every
Or
way.
John.
Is it
John.
John? Do you study this? Sounds like you do.
A little bit, yeah, on the side.
Yeah, the examples are really interesting.
I don't think I
Like
don't think I
the
agree.
analogies, to be clear.
I don't think I agree in those particular points. But the thing is, I do agree that there isn't like a sensor. Yeah.
Like
I'm
the
still curious about the
space is
form of black holes.
Yeah, so like the stuff that enters, right? its mass is immediately distributed into the surface area of the black hole. Well, maybe not like immediately; it's distributed at like the speed of light, but
Yeah.
Well, that's not hard to understand. Of course, if
Dude,
everything
wait,
has the
I have a
same
question.
density in a black hole, it will be pulled apart due to gravity in all different directions. That's not hard to understand. What I'm curious about is what form does a black hole when it's consuming matter and energy? Does it change form? Does that matter, or is the sphere
I'm
the
confused
ultimate?
about how you're using the word form, honestly.
Well, I mean, as
Like-
far as I know, people think of black holes more of a dense spherical object, right? Well, not object, but
so the mass
like a
of
round circle, maybe not round circle, but
so
it-
so the
you're
mass of the stuff it consumes immediately gets transferred to its center of gravity, and it immediately expands the horizon.
well, there has to be some
Dude, wait,
some delay,
Sus,
doesn't it?
Well, there's like I'm not sure on the specifics here, but like it adds to the horizon, right? It may add to it at the speed of light, or maybe instantaneous. I'm not sure, but it's probably at the speed.
I
of
don't
light
think
that adds to it.
so. This is where I was kind of having contentions with. All the matter doesn't exist at the event horizon. It's distributed throughout the black hole.
Well, okay,
It's like, isn't it holographically
gets
represented on the
distributed.
event horizon?
See, this is the thing I
Yes.
talk about form. So it has to fill a certain form. Let's say it's full, right? What form would a black hole that is full? Nothing else is added to it, right? What form does the black hole have in that case? Is that then the form it's looking for, and then it's actually adding, in a certain way when matter comes? Has this been observed, or is it just, well, it's just a blob? Who cares?
dude, a certain organization of matter is a black hole. So like the form, when it is a black hole, the form is a black hole, and then matter is added and it's still a black hole.
I understand. That's not a problem.
It just
What is the
grows.
form?
Like it's not. It can't get full. It's just a
Okay,
boundary
so-
that grows.
There are different types of form, right? Like,
Yeah.
are you asking like what type of matter it is?
No, I'm asking.
What are you trying to
Is
ask?
it round like a?
So what shape is it?
Oh,
Yeah,
exactly.
it's a
Geometric form.
Exactly. Yeah.
It's a sphere. Unless it has a ridiculous amount of angular momentum, it's a sphere, right? Like if you spin it up,
Would
it could.
would the
it
matter
could-
of input of matter and energy, would it matter if it if it came up close to an abundant
The
amount of
most
it?
stable form of black hole is a sphere. That's it.
Yeah, like
Okay, so is
hypothetically.
the sphere then the most perfect
Yes.
geometrical
Sus.
form
Sus.
that we can observe?
I don't know if perfect is a good word for this kind of thing.
It may not be
The
a
ultimate
perfect
thing.
sphere, but it's a pretty good approximation. Like hypothetically, you could pancake a black
Dude,
hole
you're
out
cutting
where it's
out.
you could pancake a black hole where it's a disk by just putting in a bunch of matter with a bunch of angular momentum, like spinning up like a Ferris wheel or something like that.
Yes, but
Yeah.
let's say it stops. Would it then
Oh no!
regain the form of a sphere?
If you stopped spinning it up, it would just retain its form until like
Which is a sphere, as far as we know.
Dude,
no, like
dude,
like
Sus.
if you pancaked a black hole out by putting in stuff at a very high angle of attack,
Just say spin it. I understand.
yeah, it retains its shape until angular momentum is input
That's
into
really
it.
interesting.
So it
No,
will then...
no. Wait. No, not lost, because he just said if you stopped it spinning, it would retain the shape.
No, like if you stopped adding stuff to spin it up, it would retain
Ah,
its shape
okay.
until
Yeah,
you
because-
like spun it down, essentially.
I getcha.
Basically, angular momentum is conserved. It doesn't stop spinning.
All right, but I think that there was a
What?
bit of like
Dude.
a bit of confusion over
No, I
stopping
said
it,
if it
like
stopped
stopping
spinning.
its. Yeah. See, that's what I heard. Yeah.
Yeah,
Dude,
like if,
dude, I have a question for
No, so
Sus.
actually, wait. Actually, the answer then, Lamassive, to your question is that as soon as it stopped spinning, it would be a sphere again.
Okay,
Yeah.
so we have basically a huge stress ball here, right?
kind of like a really
Yeah.
dense maximum density
Yeah,
stress
of course.
ball.
It's,
I still have a contention with
Dude.
that word.
Dude, Sus is.
Ah,
Do
Vivi.
elementary particles
Hey, Vivi,
retain
guess
their
what?
structures
What?
Do elementary particles retain their structure when getting into a black hole?
Elementary particles?
Yes, yes. They, as I said, they spiral down towards the center point, but the center
Yes, so
point
they
is being
retain their
stretched out. Yeah, so like the individual like quarks and leptons and stuff, they retain their structure as they're spinning down, right? But then the mass of those objects get redistributed around the entire black hole, and then the mass will eventually be re-emitted in the form of photons, right? So it's the only way that we know of that has a 100% mass to energy conversion, right? It's kind of one of those objects that are really good at doing that. A lot of other stuff isn't really good. Antimatter is a good example. It has a 100% mass to energy conversion.
Yeah, I definitely believe in the conservation of energy and momentum. So the conservation of all the energy is kept in the black hole, especially the fact that none of the light is emitted. It's kept inside.
But you just don't like density.
The density argument. I just don't really understand what you guys mean by that.
What do you take density to mean?
I take density to mean the amount of mass in a particular concise space. So, like, if you say
Okay, so
average,
wait. So,
yes,
like I detected before when we were talking, something I said to you, it seemed like you missed it, right? There's two types of singularities that you can think of. There's the singularity, which is the singularity of space-time. What we're talking about then is not everything being collected in one space, dude. We're talking about all the space being in one, like, pixel, right? It's not the same idea. So if we have space, right, the most dense thing cannot be a single point. That actually makes no sense, and the reason it makes no sense is that a single point, by definition, is not related to other points, and a black hole doesn't encompass everything. So if there are other points, it's ridiculous to say that the black hole could be a single point.
Okay, so we as space approaches a single point, it gets denser.
Yeah, so a black hole is like, I don't want to say the analogy again because I've used it so many times, but I'm sure, like, just remember my analogy. That's kind of what a black hole singularity is like. There's a misconception that it's just a point of infinite density or whatever.
Say it again.
But it's really just stuff spiraling in towards a point in space that is being stretched out faster than it can spiral in, right? And then as Hawking radiation emits as it kind of gives away the mass of the black hole, the stretching factor of the space that everything is falling towards, it gets stretched out less and less and less and less until eventually there's just one photon left, and it stops stretching when there's one photon left, and it just emits, right, as a maximum energy photon, like a photon that has the maximum energy. And if that photon were to hit something, it would make a black hole, but then it would instantly be re-emitted. So it's one of those weird cases, but still.
Do you know if black holes? I know that dark matter can't create black holes, of course, because they're kind of perfect. Do you know how it affects black holes at all?
Not really sure. It would be interesting to kind of because it has gravity, right? So hypothetically, you can make a black hole.
But it can't create collisions with each other, so it can't create a black hole in the same sense.
So I guess like if like dark matter has gravity, right? But if you had a certain amount of mass that couldn't become a black hole on its own, and then like it went through a cloud of dark matter, it could form a black hole prematurely. You know what I mean?
Well, it would tear apart as soon as the dark matter is gone, right? Wouldn't it?
Maybe. I'm not sure. If it forms the black hole, then the black hole wouldn't tear apart. It would have to decay.
But if it's only a black hole in the premise of dark matter because of the gravitational pull.
Yeah, but all the stuff is still spiraling inward around that infinite spiral that's being stretched out already, right? It wouldn't just unspiral itself because the extra bit is gone.
that would, I mean, in a sense, it might if the dark matter is filling in the blanks, so to say, right?
No, but
So
it's already gone on its journey down the spiral.
yeah,
So
but here's the thing. So this is your concept of it, right? That if I'm saying that if it has gravity and it's filling in the blanks of, you know, in the black, this fake black hole that's been created now, it would disperse afterwards because it's not holding together, or it would maybe be sucked into a very small one afterwards, right? Do you understand what I mean?
Maybe. I'm not sure. It's a weird use case.
There we go.
I like to think in a weird way. So basically,
That's an interesting word to use, dude.
what?
Use case.
I mean, it's a weird case.
No, but use case is not like contextually relevant. Not really.
It's a weird way that physics can be used, right?
Do you do computer science at all?
Not.
Where did you get the word use case?
Well, isn't it just a case that you're using something?
No, not really. A use case is like a scenario in which someone might use something that you've made.
Okay, well, it's a scenario in which we might use the laws of physics, right? So it kind of,
But
I don't know.
Well, we didn't make the laws of physics.
But gravity is not enough to create a black hole, correct?
Yeah, but it would already be spiraling inward, so it would have to decay over natural. Like the volume, or the, how do I say this? The surface area of the black hole might expand after the dark matter is gone, but I don't know.
Hmm. Well, okay. Well, I mean, maybe you could say that maybe dark matter would be the mold to create, you know, the black hole in that case.
That would be a really good weapon, though. You just send a bunch of dark matter towards a planet, implode the whole thing, and then dark matter leaves and the whole planet just explodes.
Well, I mean, if I mean, since you know dark matter has, well, we assume that there is dark matter, right? So you should be able to move it, right? Or at least interact with it in some case. You can't have collisions with it. That's the problem.
I guess you could have like a gravitational tractor where you have like a bunch of mass.
Yeah, something like that, right? Or you could suspend. What's it? This would be much easier in Swedish.
Or like you could have like a bunch of mass and then start pulling dark matter through space, and then just before you get to the planet that you want to destroy, you take the mass that you were pulling it with, and you separate it like evenly, and then it may just
you'd have a mini black hole, probably like a centimeter, and it would be enough.
Yeah.
Yeah.
I wonder if you can compress dark matter too.
I'm still very skeptical about what even dark matter even means. If they mean neutrons that we don't detect, I can agree with that. If they mean antimatter matter pairs that are undetected,
well, I mean, it's a theory, but we can't prove dark matter, but we can see that there are things that affecting regions of space and stuff like that.
We don't see things affecting regions of space.
That's not what dark matter is, dude. Dark matter is like our recognition of the ridiculously huge difference between what we calculate the mass of the universe to be and then what it actually is measured to be.
I think they came out with like photos of like where dark matter is. Like there's this one photo that I've seen, and it's like this region, like this kind of like cube, and there's like this blue stuff, and they're like, yeah, observing.
That's not dark matter then.
No. Like they say that like observing all of this stuff in the space, like the normal baryonic matter, and seeing extra gravity, we can kind of infer that dark matter must exist in these places.
Yes.
Because of the stuff that is
but
going.
Dark matter is a placeholder until there's absolute knowledge about it. So
yeah, it seems kind of foolish to say in these places, realistically, because if you admit to not knowing anything about it, that's, you know, Yeah, I think you should just stop there.
Well, I mean, like, we can see where it is.
As far as we know.
No, we cannot necessarily
Oh
see
god,
where it
as
is.
far as we
We
know,
can
yeah.
see that it is there. I'll give you that much and not more.
Yeah, like, we can see the regions of space where it must occupy.
No, I don't
We
accept that.
We can't directly see it. We can only see it with
No,
inference.
I don't accept the inference. I don't accept the inference. I'm saying
Then how do we
the observation we're making of gravity could be a consequence of what the dark matter is, not what it actually is.
Yeah, we say there is dark matter that explains the gravitational pull on certain objects that we have calculated, but not necessarily observing. Something that creates that effect.
But at this stage, dark matter would be the same as, for example, microbes, whatever, like 500 years ago, perhaps.
No, I don't think that's a good analogy.
Why not?
Like, we can see gravitational lensing where there isn't enough baryonic matter to do that amount of lensing, and then infer
Yes,
that
I
dark matter
understand.
must be
No,
there.
no,
right?
but the inference isn't sound because when you call it dark matter, that's a convenient way to describe it. It helps us grasp it, but you can't go as far as to make the assumption that whatever is producing that effect is like appropriately described as a type of matter that we would recognize. There's no necessary like inference to be made that the effect that we observe on our world translates to something which should be described as dark matter, as in there is dark matter in this space. You know what I mean? Like, maybe in a metaphysical sense, something is passing through our space. We really do not know enough about it.
Okay, well, we can say that there is extra gravity coming from something in this region.
We can
of
say,
space.
yes, no, we can say there is extra gravity in this region of space. That's what I'm willing to say.
Yeah,
Not
but
that it comes.
we just said that it's a placeholder.
No, not that it comes from something in the region of space. I'm willing to say that we observe extra gravity in the region of space and nothing more.
Yeah, but then...
And as far as we know, that would mean that there is some sort of matter, and that's why it's called dark matter, because we don't know what it is.
No, because why we call it dark matter is because, like, it's a convenient way to describe it. What we mean is
that's what I
gravity.
just said.
No. What it is unaccounted for gravity. That is all it is.
Yes, and we do think that
dark matter is about no, but there's no necessary inference since we have not made any observations of the matter and we've tried, right? There's no necessary inference that it actually is matter. The fact that we can observe gravity does not necessarily implicate matter.
That is true, and that this is just a theory, right? Just like
no, but it's not a grounded theory. It's just a name.
It's a hypothesis.
It's just a name to describe the
extra
gravitation.
Is it the name you're objecting, or that?
Yes, and I'm just saying, like, when we're talking about whether or not that means that there's actually extra matter in the space that we are not observing, I don't feel like that is reasonably substantiated by the simple fact that we call it dark matter.
Do you think that this is semantics, or do you think that you are afraid that if it's called dark matter, it will become an axiom for a lot of people?
I mean, like, it's okay to call it black matter, but you can't say that there is matter stuff there.
Yeah, that's what I'm saying. I'm saying, like, all I'm willing to cop to is that we observe extra gravity, you know, and we call it dark matter. I'm willing to use the label, but I will not accept you making inferences about what the dark matter is based on the fact that we called it dark matter.
It can... Generally speaking, it must contain some amount of energy in order to bend space.
Yes, I accept that. But what does that mean in a metaphysical context? We don't really know.
Okay, so, and since energy and mass are equivalent, right?
In physics. Physics.
Actually,
yes, I'm saying.
No. Actually, no. I'll say immediately no. We say energy and momentum are somewhat related. Mass and energy are somewhat related, but they don't.
No, there's an equivalence, Vivi. There's an equivalence.
Does light have matter?
Listen. E equals mc squared. If we take out c squared, which is the speed of light, right? Then we have E equals m. Now that is by definition an equivalence.
Yeah. Well, he
that's
is
not
right.
the original equation.
Yeah,
but that's not the point. The point is that E equals m plus something else means that energy and mass are equivalent, and there's another element as well.
Yeah,
Mass
so
is a form of energy.
Yeah,
But-
so in physics,
Yes,
mass
that's what
is
equivalence is.
mass is just energy and momentum, right? So in physics, energy and momentum are equivalent to mass, right?
Yes.
Yeah, that's why if you take a bunch of light, right, and you put it in a box with perfectly reflective mirrors, it'll pretend that it has mass just from the redshifting of the light, right? So it's kind of like, even though the photons don't have any mass, since they have momentum, it'll act like it has mass.
I'll accept it has momentum.
Yeah, but like the way that redshifting will work, it'll act like it has mass, right? So energy and mass are effectively equivalent. Sort of.
Do you guys think it's pretentious?
I'm gonna say
from the little what we understand in our region of the universe, like the little we understand. Do you think it's pretentious to assume what's happening far, far away?
No.
Why not?
Generally, if the laws of physics work here, there's no reason for us to assume they wouldn't work over there, right?
Yep.
Because of well,
Because we assume continuity of nature. Most
Yeah.
scientists do.
Well, yes, to go somewhere, to have some sort of
No, I'm saying like
stepping stone.
I'm
right?
just saying
But-
like yeah, but like that seems reasonable enough to most of the people who are thinking about it. And if you assume that, it follows rationally that they would be the same there.
I think what my main contention with the previous point was this. I think angular momentum may have may manifest itself as mass, but I don't think that you can just say energy in general is equivalent to mass.
I'm gonna show you a Quora answer from a guy who has a PhD in physics, where he talks about. It's a question someone asks about how photons can have no mass if they have momentum or energy.
Yes, I accept that they have momentum for sure.
No, but he explains how they kind of have mass.
Yeah, if you put hold on.
No, I'll show you the explanation, man. It's written by a guy who's very qualified in the subject.
So I think I'm gonna have to definitely look up the definition of mass and definition of matter.
No, it comes down to like the way that the way that he like works it out to be kind of mass.
Hold on. If you put photons in a box that has perfectly reflective mirrors, right? And you accelerate the box in one direction, it will resist acceleration due to the way that redshifting would work in that contained environment, because photons have momentum, right?
Okay, you're gonna have to repeat that for me. You put light and there's mirrors
in a perfectly reflective box, and then
Yeah.
you try accelerating that box, right? It will resist acceleration because of the redshifting within the box.
Yeah, I'll concede to that. Yeah.
Right. So in that sense, energy and momentum are equivalent to mass. Right? That's why mass in like more like
No,
theoretical physics is equivalent to energy and momentum.
Space in of itself. You're saying space in of itself has mass.
Vivi?
Yeah.
Yep.
You're saying wait. Are you saying wait? I'm gonna repeat that. Do you say space itself has mass?
No.
So then explain exactly what happened with those mirrors again.
Okay, so the light will redshift so that it will act like it has mass.
Wait, you know what's? I'm reading about this right now, right? And it was just, I don't know. I was checking my photons and stuff like that. This is the example you're talking about, by the way. I think, if you want to read in Tavern text chat, I think I'm there. Is that the one you're talking about? I think it's better present than there.
Which one?
In Tavern text chat. However, if light is trapped in a box with perfect mirrors, so the photons are continually reflected back and forth, blah blah blah. That thing.
Yep.
I think
what you're
what
talking about?
I would say in the case that the lights in those mirrors and the photons are bouncing back between the mirrors, and you travel vehicle travels in one direction, the rate of photons hitting on one mirror would be more than the rate of hitting in the other mirror, and therefore there will be a transfer momentum in the backward direction, which would resist change in velocity.
Yeah.
And if you say the definition of mass being is a property of a physical body and a measure of its resistance to acceleration, photons in themselves don't resist acceleration. However, this system particularly set up will resist the change in
Hey, Vivi.
Yes.
Yeah. The
Yeah.
system is
Just
a
give me 1 second.
demonstration of why energy and momentum are equivalent to mass, right? So photons don't have mass on their own, right? But this is just a demonstration of how that can lead to mass.
The thing is, the problem being is we're saying mass is a resistance to change in acceleration. Wait. All right, go ahead.
So like, hold on. So
Have in text chat.
Yeah.
Read that
yeah.
for me.
Like if you look at like Einstein's equations, right? E equals mc squared isn't the full equation, right?
Yeah.
Like it mentions p in the equation a lot. So it's kind of
And yes, and we have to also know what this equation is talking about. This equation is particularly talking about an energy contained by a particle that has mass.
Yeah. So in this context, right? You can think of the box with light in it as a particle that contains mass because of light's momentum and energy. I don't know. There's more interesting stuff to be talked about, though.
Yeah. Here's the thing. This is the contention I have. If you say energy is mass, then notice that energy is a potential for an object to have change in anything, like in position or rate, and on the contrary, mass does the opposite. It resists that change.
We didn't say they were the same. We said they're equivalent.
I'm not saying like they're not the same thing. They're just equivalent. Yeah, like I don't know.
You can change light.
They're equivalent.
Wait.
That's equivalence.
Okay, so
like they are
I will agree.
properties. Like there are properties that are proportional to each other, right? So like the more mass you have, you could turn that into equivalent energy, right? Kind of like in atomic bombs, right? So
Yes,
they're
I
not
do agree with that.
The equivalence is very well recognized, man.
Yeah, like that's kind of why on the periodic table, right? You take the mass of the hydrogen atom, right? Two of those, like two deuterium atoms, do not directly add up to the mass of a helium atom. That's kind of what people take advantage of in the production of hydrogen bombs, right? So it's very, very well documented.
Yes.
Yeah, very well documented.
Correct. I do agree with the notion that things like light can be turned into mass, and things that have mass and things mass can be turned back into energy as light or electromagnetic radiation, the more proper term. I don't disagree with that. I just think to say they're equivalent, that I think maybe the word itself is what I'm having contention with. Equivalence. What does equivalent mean?
Yeah, so like in physics, energy, matter, and information are all equivalent.
Okay, so this is the thing, right? Equivalent means equal in value, amount, function, meaning, etc. But the thing is, it's not equal in function at all.
It's equal in amount, though.
Equal in amount of what?
Like
energy to matter, for instance.
You're not going to get more energy out of like a hydrogen atom fusing with another hydrogen atom than the amount of energy that is missing when adding up hydrogen atoms.
Mathematically, there is a recognizable and demonstrable fuck, what was the word again?
Correlation.
So I'll accept
equivalence. There's an equivalence.
I'll accept saying that light, electromagnetic radiation, and mass are equivalent, and the equation that relates them is E is equal to mc squared.
Yeah, that's fair.
Yep.
if we want to dive one layer further, information is also equivalent to energy and mass, using like the holographic principle, which is pretty cool.
I think that that one just sort of collapses into my view, but we don't have to talk about that.
I'd encourage you guys just to check out like the holographic principle. And
I understand the holographic principle really well.
Okay.
I think that the inference that you're making isn't appropriate for physics because it's not the domain of physics.
I mean, entropy is pretty much everywhere in physics, man.
Yes, and entropy is not something that physicists, or it's not something that people who study physics from a non-academic perspective tend to understand, because entropy seems to be randomness, and it's not that at all.
Yeah, I feel you. I feel like just going back to the work of Boltzmann and starting from like nothing when understanding entropy is key.
It's an interesting thing to say because I actually understand nothing very well.
I feel
Wait,
you, man.
is that possible?
Who knows?
Yeah, nothing, like true nothingness in our universe doesn't really exist. That's kind of what I think he's alluding.
Alright, so if you understand
Well,
nothingness very well...
I personally say that nothingness is ontologically impossible.
So you understand that it's impossible, not necessarily understand it, right?
You asked me if I understood it very well, and I said, I wouldn't know, or who knows. So I don't know that I understand it very well, but I think I do.
That's fair.
Fair. Very fair. No, but the thing is, like, to understand it means you'd be able to... I don't know. That's probably
I've done an analysis of the concept.
Okay, so yeah, so nothingness is not black, nor is it white, nor is it anything.
More like, what is it that we mean, for instance, when we say nothing? What is it that we mean when we add ness to something? What is it that we mean when people talk about nothingness? What's the difference between the nothing that we would use in casual conversation and the nothing that people mean when they're talking about things not being?
I see.
You know what I mean? Like,
Yes.
What exactly is this thing? Yeah.
Do you think that the probability that the universe could come into existence predates the universe?
Nothing ever had to come into existence because things always were.
Yeah,
I actually agree with that.
That's kind of what I'm thinking as well.
And I don't think it has to do with probability.
Yeah, like
it doesn't.
Often when I'm talking to like Christians that are trying to hammer home their ideology, and they're like, "Well, nothing can come from." I talk to them about how the probability that the universe could exist predates the universe, or else we wouldn't be here, right?
I still don't like using.
That's bad. It's bad language. Like I feel like I know what you're trying to say, but
yeah.
Is my mic working here?
Yes.
Like, how would you change the language to be more suitable?
Okay, so like they say nothing can come from nothing, therefore something had to create things, right?
Yeah, that's kind of their whole.
But the thing is, they presuppose.
But you can just say, well, I agree, nothing can come from nothing, and it never has to, because things always are.
Yeah.
That's fair.
The thing with probability is that probability is the repeated measuring of occurrences, and it's basically measuring the outcomes of said phenomena, except we don't have universes to compare this universe to, so making any like statements of what the probability of this universe is to is fucking insane. It's fucking stupid. There is no comparison to make.
Well,
It literally goes against every notion of probability.
I guess quantum computing may disagree with you there, but you know. Isn't the whole like property of quantum computing comparing to other possible like options? Isn't that the whole idea? Like superposition and all, right?
I think the quantum theory is still not exactly very well developed.
I mean,
If
it's developed enough for us to make computers using it.
yes, it helps us predict certain outcomes.
Yeah, that's fair.
But I don't think it would be based on randomness. I think that's what I'm kind of trying to make sure that I'm saying.
Yeah, that's fair. Gotta go for
Randomness and all that shit with quantums. I don't know enough about it.
Randomness is a very commonly misunderstood subject, though.
Nothing is random.
Is that a predication about nothing?
Ah. Then there isn't anything that is random. Better.
That is better, yeah.
That's a good question, though. Is nothing random?
It's funny because like when I made the joke, I thought to myself like, it almost rings as if a mistake from the past, you know, like one of those secular things that someone who could actually see says, and then someone else hears the other version.
Yes.
Do you want to continue out this fucking Will? God damn it! No, he left.
Shit.
Wait.
Wait, but like, what if somebody defines random as things that are seemingly occur with that seem to occur without a reason, because we don't know, not enough information has been presented.
Yeah, that's a good definition, but that's not what people mean. What's with your DP, Vivi?
What's with my what?
Your display picture.
Well, a friend of mine asked me to have this on, and so I did.
Why?
Because friend.
No, that's not what I'm asking.
Why
Why did your friend want you to? Although I find it funny that you immediately jumped to defending your decision to do what you were told.
So why did my friend ask me to do it? They just suggested it, and so I was like, okay.
Okay. Okay. Okay. Okay.
Because they're not the same is we shouldn't assume two sentences are the same. The whole I am lying and this sentence is false. They're not identical, right? So that's the first thing we shouldn't do. But
I didn't say they're identical. I said they're similar.
okay, well, similar is exactly enough different where we should just isolate them. So the
They
following is
literally
just
use different words. However, I would posit that they have the exact same amount of emptiness within them.
I just don't care because my anecdotes are more true than the work of scientists all over the world to validate a theory.
No, dude. It literally goes back into, unless you're trying to say that the example that I gave was a false equivalency, like it literally goes back to the same thing. If I've lived through something and I see that like this is true, and you give me like surveys and like hundreds of years of research that tells me
But like when you're referring to the principle that governs everything, you're referring to data logic, as far as I can tell. Of which, you know, if you wanted to like refer very specifically to the principle, would be relativity. You'd say like the.
I think what I'm actually trying to say is the principle that governs how data forms.
But data doesn't form.
Like how the data is differentiated.